right. Hi, everyone. My name is Nicolas Roth. I used to work on ConstraintLayout and MotionLayout at Compose. John?
My name is John Hofford. I still work on ConstraintLayout and Compose.
All right. Let's go next. So before we go on to the specific of ConstraintLayout in Compose, let's do a very quick recap on the current functionality of ConstraintLayout. So we started with ConstraintLayout 1.0, and you can think about it as, on one hand, we were doing some XML parsing from providing a view group. It all was essentially fed into what we call core, which was essentially a solver for the different constraints that you had to position your elements. The other important point was this concept of constraint set, which essentially allow you to extract all the rules that you are using for your layout and keep it into a constraint set object. So ConstraintLayout 1.0 essentially provided you with a very flexible layout manager, with the gist of the approach being to deal with relative positioning. And you could do that in very different ways. You can also specify the various dimensions with ratio, etc. One interesting concept was the concept of additional helpers objects, like guidelines and barriers. And we also provided the layout editor support in Android Studio. All right, so in 2.0, we essentially build up upon what we had, but adding a couple of items. One, we kind of made the helper concept, like those guidelines and the barriers, we made it a first-class concept. And now you could actually, not only does the library can provide to you more helpers object, but you can actually create your own helpers object, which is kind of handy. And of course, the biggest addition to 2.0 was MotionLayout, which provided a declarative way of creating complex animation and motion handling with touch gesture management. So the other thing that we had in 2.0 was the concept of virtual layouts. So it's kind of expanding the concept of helpers to the equivalent of what would be a layout manager, but still keeping everything nicely put down into the constraint set. So you could essentially rip out all the constraints or reapply them to an existing layout. And that come in very handy when you want to do stuff like motion layout animation and essentially providing state management like that. We also added decorators and helpers object and etc. The 2.1 release was a little smaller, but we got a couple of interesting stuff with constraint properties to provide a nicer way to programmatically create constraint set. And more additions in motion layout with view transitions and additional motion layout helpers. Specifically, we added a couple of virtual layouts like circular flow, reactive guide, which is very handy to deal with things like foldable, and a few niceties that we really should have done before, but supporting negative margins for the relative constraints and expanding upon the baseline constraints. I know you can actually connect the baseline to something else that is not a baseline. Just to give you a taste of what it looks like on foldables, and here I'm just playing that in the emulator, but you can find all of that in the training guide on developerandroid.com, and you can see that the layout reacts to the presence or absence of the fold. The other thing for the baseline, as I mentioned, you can now have a baseline relative to a top or bottom, and you can also support negative margins, which is kind of handy.
So constraint layout, in 2.1, I'll go over a little bit more of constraint layout, 2.1's motion layout features, because they are actually significantly large, and also they kind of relate to Compose in the long run. So we had a lot of features: rotation support, view transforms, unswipe springs, interpolators, animated text, motion helpers, and a few APIs to help with scalability. And I'll go through a few of them here. So one of them we see here is polar mode, which is essentially a lot of rotation support. We can do lots of complex interactions. We also can even handle rotation of the phone. So in this particular picture, you can't see because it's not a phone is not live, but as you can see, the widgets are being rotated. And so we have APIs to help with that. So really we've added quite a bit in that kind of thing. One of the big new features there is view transitions, which essentially provides us with the ability to make a mini transition just for a single view. And it has lots of features and lots of options. The other feature we want to sort of mention here is spring support, which is there have been requests for things to shake like springs. And so now on swipe, when you let go of swipe, it can actually act as a spring. Another feature we have is quantizing the motion. So you can actually, if you wanted to simulate a ticking clock kind of behavior, you don't have to do some weird set of a bunch of little transition steps or something like that. You can just specify it. Another very useful feature is motion label. That's actually providing you with kind of many different styles of animating of text. So within MotionLayout, it's really optimized to be used within MotionLayout.
So the other thing that we want to highlight as a motion helper is the motion effect. So you can imagine where in this example, I'm toggling between those two states, right? And essentially just moving around those boxes. And well, really that motion looks super ugly, right? It looks very chaotic, and this is clearly not what you would like to go for as designer or programmer. So motion helper lets you specify a specific effect given the direction of movement. So in that example here, just by adding that motion effect, dropping it into your layout, it will reference those elements, and depending on their direction, will apply the effect. So it's super handy to very quickly have something a lot nicer and kind of piggybacking back on the motion layout states. Another thing that's nice is, well, this view transition stuff that John just talked about, you can actually reference it, so you can really customize the type of effect you apply with a motion through motion effect. So it's very, very handy. The other helper that's kind of cool is Carousel, and you can find the developer on Reader.com training guide on how to use it. More information as well on the GitHub page on ConstraintLayout. But essentially, it's not a replacement of Recycler View, but it fulfills the same stuff where you have a list of items. It's more like when you want to do this kind of really crazy transformations, well, here you can do it within MotionLayout and using all the normal stuff you do with ConstraintLayout. So it essentially gives you a lot of powers and flexibility on how you want this type of animation to go. If you have a simple list, just use Recycler View.
So one of the things I wanted to just sort of point out is the latest material you calculator. So if you have the beta, and it kind of talks to 2.1 operating at scale. The entire calculator is essentially a motion layout. It has about 11 different constraint sets, so states. You can think of it as whether the invert button is pressed, or the text is down and up and scrolled. So a lot of different transitions, a lot of different effects. It even has view transitions on the buttons to be able to, when you click on them, to react to them with changes in shapes. And so you can sort of see that within Google, within Android, it's being used in kind of this sort of larger scale. It's an incredibly complicated piece of XML, a series of XMLs, and a lot of the includes and things like that really helped with making it a very scalable solution.
So that was ConstraintLayout 2.1, and we, as John mentioned, we kind of try to focus as well on, flexibility and scalability to handle this kind of really complex and multi-state UI. So for Compose, what did we do? We took essentially the previous architecture and replaced all the front end with Compose-specific adapters and etc. But the concepts are the same. And more importantly, the core engine that we talked about, it's the same. So we are simply, it's actually a separate library, and the ConstraintLayout in Compose library is just a front end to that core engine, same as the ConstraintLayout view library is a front end for that core engine. So looking at it a little more, we added a few things into that front end. First, you can actually specify the constraint using a Kotlin DSL. And we'll cover that a little. And we also are exploring something interesting using JSON to represent those constraints. I would stress that all of that is work in progress. We are actually getting close to the RC for the 1.0 for ConstraintLayout Compose, but this is the 1.0. So there's obviously a lot more that we are planning to do, and we really want to hear from you as developers. Our job is really to provide tools, to make your life easier, right? Next. So comes to the question about why do you want ConstraintLayout in Compose? If Compose is this brand new framework with different type of layout than the view system. Well, the first thing is that ConstraintLayout in Compose provides a migration path. So if you are used to ConstraintLayout and you want to relatively quickly move to some of the complex layout you want to do, ConstraintLayout is available in Compose. That's the obvious one. Relative positioning is the other reason, in the same way that, beside linear layout, you had at the time relative layout or constraint layout in the view system. Similarly, in Compose, we are using rows and columns and, things like that, which you can use to build UI. But if you do prefer to specify a UI layout with relative positioning, that's where constraint layout shines. Some of the performances reasons that we had in the view system do not apply as much with Compose. So, depending on what you want to do, feel free to use rows and columns. But essentially, it's like any time that you have a UI where it makes more sense to specify it with relative positioning, that's where it's for. The other aspect is, this whole concept with essentially extracting the constraints, rules, and all of that, and reapplying them, etc., provide a nice way of doing a separation of concerns between those UI rules and the elements you actually want to show on screen. And so that's a nice way to do that. With Compose, you can also do that differently with different composables and swapping them, etc. But this just provides another path. So here is what it looks like. A couple of things to note here. You see the preview on the right, because there is indeed an integration in Android Studio, and you notice that we're actually showing you the constraints, so you have a visualization of those constraints in Studio. And essentially, that composable, it's not too complicated. You have the two composable button and text, and they map to those elements you have on screen. And in fact, if you click on the preview, it should go there and vice versa, at least highlight them correctly. Now, the interesting thing is, how do you specify those constraints? Well, they're simply specified as modifier, as most of the stuff in Compose. And essentially, that modifier just provides you a context where you have a DSL, and you just type the constraints like that. So the thing that is really cool is that it's a Kotlin DSL, so you got all the advantages of Kotlin integration. You have the not just syntax highlighting, but code completion and etc. And the other thing that's interesting in that example is the guideline. And guideline here, while on the view system, you had to create a view as a guideline. That was really due to the fact that we did not have as much control on the XML parsing as what we would have liked. While here, we don't really need to do that. So the guideline can just stay as something that is not composable. It's truly just a helper for your layout, and you just create it like that, and you can then reference it in the rest. So we mentioned like this separation of concern, because while you can specify the constraints directly as modifiers in your composable, there's another style, which is, well, I'm just specifying an ID for the composable. You notice here the modifier.layout ID button and title in the bottom. And you move in a separate constraint set all the rules for the layout. So that means that you can have your list of composable where you can just focus on their behavior, their appearances, and stuff like that. And the way they are laid out can be, pawned off to a constraint set. And obviously here, we just declare the constraint set in line within the constraint layout. Nothing prevents you to create multiple constraint set variables, stash them somewhere, and pass it to the constraint layout function, right? So that's here just to show that on the same slide, but I would not be surprised if you would actually create your constraint set somewhere else. So here's an example of what we talked about with the JSON exploration. So this is the exact same constraints as what I showed in the previous slides, but this time it's done in JSON, or more exactly JSON 5, which is a superset of JSON that makes things a little more readable by removing unnecessary quotes and stuff like that. What's nice is that you do support it really well in Studio. We do support essentially like the syntax highlighting. We support, there's some error checking. There's more that we can do there as well. But there is some to start, and it's just like a multi-line string, right? So there's nothing is complicated here. This is just a string. So obviously that could lead to some interesting, runtime behavior in your UI where you just pass a different string, or you load it from somewhere else. Notice as well that as far as the constraint layout composable itself is concerned, we are just passing a constraint set. It just happened that this particular constraint set, instead of being initialized from the Kotlin DSL, it is initialized from the JSON 5 string. So the other thing that is kind of handy is that because it's a string, all the live literals capabilities in Android Studio work. And here I'm just modifying the margin, and you see it reacting it live. But in fact, any modification of anything in that constraint set would be interpreted instantly, contrary to the DSL where you would have to compile and wait a little bit. So the other thing that's handy with this version of constraint layout is that if you create two constraint sets, as I mentioned, you can easily create multiple variables for your constraint set. So notice at the bottom, I have CS1 and CS2. I just initialize them with the strings just because I think it's simpler, but obviously you could initialize them with the DSL as well. So I created those two constraint sets, and we can just pass that to the constraint layout. And notice here, there's something cute, is that I just say the actual constraint set I'm passing depends on this animate to end flag. And if it's true, I pass CS2, otherwise CS1. And when you click the button that animate to end, a flag changes. And by simply setting animate changes to true, we can just animate the entire stuff. So it was simple to just specify the original, constraint set, and notice what it does here. Notice the rotation X 360, that kind of forces it to actually do a full rotation like that. And I didn't have to bother with the rest. The MotionLayout engine underneath is actually doing all the interpolation. So if we look at how it is implemented, and just as curiosity, you'll see that it's a normal composable function. But if animate changes is true, we just call MotionLayout.
So that brings us to MotionLayout within Compose. And as you can see, it's actually being used under the hood in ConstraintLayout for when you say animate changes, to provide a handy little function. So you can think of it as, oh, I just give it two different constraint sets. And then you're sort of tapping into the power of MotionLayout. Some key things about it. In the short term, we're heavily focused on the JSON 5 version. The strings, because we want, if people use it right now, to experience and give us feedback on the JSON 5 string, because there are a lot of subtleties to it and a lot of capabilities to it, and we'd like people to explore it. You can sort of think of the MotionLayout version right now as a bit of a limited release to get a sort of a feel for what people think about it and get feedback. And so it is a bit of a limited subset. So let's take a little look at what that syntax looks like, the JSON syntax for it. And we'll just focus on the syntax. You've seen how we construct the things. So a motion scene in MotionLayout will have a header typically, or it doesn't have to actually, but a header that will give it a label, and you'll see where that label can be used later. But it might also have things like metadata, like debugs, please show me the debugging lines, things like that. It also has a constraint set, of which you've seen before. Nicolas sort of went through a little bit of it. It's the exact same constraint set. There's also a transition, which the transition is the same. If you're used to MotionLayout, the transitions are exactly the same stuff. So any of the attributes of transition that you used in the old MotionLayout in 2.1, you'd be able to use they're named a little bit different and a little more compact, but quite useful features. Like in this particular case, the path motion arc says move in arcs. The keyframe section is now kind of relatively different, and we'll kind of go in a little bit of detail on it. Here we see a key position and a key attribute. In fact, only key position, key attribute, and key cycle are currently supported. It's a little complicated as to why the rest of them are not supported yet, but we are working on it. So one of the things you can sort of see in these keyframes is that it's a lot more compact. What we're seeing here is 4 keyframes applied to a target button. If you wanted to apply it to 3 different targets, you could put button 1, button 2, etc. The shape of it is a sine wave, and it has 4 keyframes, 0 at position 0, 20, 68, and 100. And you could sort of see where they're represented right there. If you look at what that would look like in the XML, you'd see that it's a lot bigger. So the JSON syntax is really helping compress the entire thing, make it a lot more efficient in scale and very easy to process in your mind. Here's a little example to kind of give you an idea of us doing something that's there. You see it's a large motion scene, and it has lots of capability. But if we run it, this is the UI, and we're transitioning between a few different states. So this is a composable that's just transitioning between a bunch of different states, and you can sort of see how that would work. And it's live, so you can change things. You could modify different attributes, make different UI changes on the fly. I just gave you a very brief overview of the stuff, but in fact, we have lots of examples on our website, and you can, if you click on the link to the right of it, it'll take you to the code. You can find other different kinds of behaviors and how to achieve them, and different effects, and sort of try to get a feel for all of it. The other thing to know about this website is that it has like issues. It's a GitHub. You can, give us feedback, things like that.
So yeah, just to go back a little bit on the JSON 5 itself. So again, this is I would consider it a little bit as an experiment in the sense that I think there's a lot more we can do with it, but it's already usable, right? It's already in the 1.0 library, and anecdotally, personally, I find it super useful. But that's definitely one of those things where we would love to get feedback from developers. So to recap a little bit, the disadvantages that you could look at is, well, it's another syntax to learn. I guess theoretically there might be like some, impact on the performances compared to the compiled XML that we are using. In practice, I have not really noticed any difficulty or concern with the performances. The parser is actually pretty damn efficient. But definitely, if you have examples where things would get slow, tell us, because that's an area that we want to make sure works well. But again, not anything I have seen so far. The main advantages from us, one, it's a lot more compact, as John just showed, than the XML syntax. Also, it's a syntax that we do control, so that means that we can come up with kind of interesting new functionalities. We are not tied automatically to the basic like view groups pattern in XML. It's also much easier to have something that is cross-platform with that, because at the end of the day, this is just a string. So that means that if we want to have ConstraintLayout Compose on the Compose desktop, that's much more doable, for example. It also works really well with the current state of the tooling support in Android Studio, as you saw, like with the existing implementation of live literals in Studio, you got an instant update. And by the way, in the videos we were showing, those live literals were in the preview. Live literals also work if you have a device, a physical device connected to Studio. And finally, it's kind of a nice way of doing a separation of concerns as well. And there is something more that we'll talk about with something called link. So just to give you an idea on the type of different type of syntax we can come up with, I have this example here. So here it's just talking between two different states, but what's interesting is how I built these examples. And how I built it was, I have the compose side of things is just a for loop, just adding a bunch of boxes and having them tagged with the tag box, right? But in terms of compose, this is just that, just a for loop. And by essentially mapping that particular JSON, on the left that you see, we can position all those boxes. So a couple of things that are interesting here. We have this concept of variables, and they are, more than variables. You have some normal variables like distance is just a value, but you have also angle and rotation that are what we call generators. And essentially what that means is that every time you reference that variable, you see in the generate section on circular, for instance, we have circular, which is a circular constraint, go from parent with a given angle and distance. Every time that particular rule will be hit, a new value will be extracted from the variables side of things. So each time you call angle, it will increase. Each time you call rotation, it will increase. And that makes it, a very kind of straightforward and very well-defined way of specifying complex, unbounded type of constraints, right? Which is one area that I think in the normal XML world would be very difficult to do for us. And the other stuff that makes it work is this mylist idea, where mylist simply give you a list. It's a variable that we initialize with the list of composables that have been tagged. So you don't have to specify the specific IDs or anything like that. By just doing that, you get a list, and then that generate section apply on that list. So I think it's going way too fast to get all the subtleties in that particular presentation. But the gist of it is that in it really opens up a lot of interesting doors for us to evolve the syntax and evolve how we can specify constraints in a more declarative and a more compact way. And you notice here that we can modify the JSON and it reacts instantly in the preview. So another thing that we've been playing around a little, it's Link. And you can go download it on the GitHub website. And that's, just to set things, to set expectations well. This is purely an experiment. It's kind of like a playground for us to see what kind of tooling we could build upon the capabilities of JSON and this new approach. Right now, it actually works just with Compose, but one of the interesting things is, on paper, nothing really would prevent us to make that work for the Vue system. So that may be something in the future releases of ConstraintLayout for the Vue framework, where we would support this JSON approach for specifying the constraints and tooling like Link. And again, Link is just an experiment, but the idea is, if we have something interesting that we can, flesh out via Link, we'll try to make it. We will try to make its way into Android Studio ultimately. So what is it? Essentially, this is just a front-end application that runs on your desktop. It's a Swing application, so it should run everywhere. And you essentially connect it to your actual Android application that's using ConstraintLayout and MotionLayout. And right now, as I mentioned, this is ConstraintLayout, MotionLayout in Compose. So it's just that. It's just like, think about it as an inspector. You connect to it through an ADB tunnel. And it's pretty straightforward. Right now, the way you would do it, and again, you can look at the GitHub on how we do that in a couple of examples, but you just add this Link server Kotlin file in your project, create an ADB tunnel between your computer and the device, and just run the desktop application, and that's all. Just to be clear, those examples show the emulator because it was easier to record, but that would also work with a physical device. And right now you have to include this class because we didn't release a library, but really we should just release a small tooling library so that you could, for example, in your debug build, you could link to that. So what does it do? When you do all this connection and setup, you can start this application, and it will show you all the different constraint layouts that are available on screens or that you went through. So once you click on one, and here we essentially click on the one that's present on screen, we are going to pull the JSON file straight from the device, and you can actually see it in the editor. We provide other tools like a visual inspector, and you notice here that, well, it matches what you see on device. Notice as well on device that we did turn on the debug flag in MotionLayout, so that's why you see the path of motion on the device. But you can see that all the inspector works and match the device. We have an attribute inspector as well. We have a timeline. It's actually the same timeline or the same code that we're using in the motion editor in Android Studio. So you have visualization of how values change over time, etc. So it's even as a prototype and as a proof of concept, it's kind of really handy because you can essentially inspect live something and see, and trying to understand how things work. And what's really interesting here is that we are not dependent on Android Studio or the layout lib approach or anything like that. All you need is to actually run a real application on your device. So the other thing that we can do is, now that we've got this JSON 5 locally on your desktop applications, we can edit it. And just as a quick demonstration, we implemented some basic graphical editing of here guidelines because they are super easy to implement in terms of interaction. So, and you notice that if I modify those guidelines, the JSON on the left did change, and more importantly, we push that back to the device. If I select another, like this button that's on the top left of the screen, I can also use a right-click menu to add constraints on the fly, and you see that again, it it updates live on the emulator. The other thing you can do, and that's kind of interesting as well as a direction, and again, caveats, this is a prototype, proof of concept, but we have this idea about providing support for design elements. And notice that essentially here, I started on a UI that was blank, there was nothing, and I just added design element on the fly in the JSON, and they are showing up in the screen on the device. And what's even nicer is that the mapping between those elements, for example, the image type that I'm adding here, is something you control as a developer. So in your application, you can actually add more mapping and add some other components. So you could imagine having a library of components, expose it to the link server, and we will know how to interpret it and load them on the fly. Another thing that is really, really cool is you notice here that the image is actually being loaded. And that's something that actually we could not do. Oh, can you pause, John? 1 sec. Just we're going a little ahead of ourselves. So the image is actually loaded from the network. You see that I just specified this image, it just specified an URI, and we just loaded it, which is not something we can actually do in Android Studio preview mode. Oh, yeah. That's okay. So that just builds upon like this thing that, well, you are not actually trying to do a simulation of what's going on. You are just playing with the real application that has access to all the real capabilities of your device. So that's I think is a very powerful shift in how you can think about this type of authoring tools. And again, like a lot of the issues that you may have with the preview approach, where you have to, in the Android, with the view framework, where you would have to create, fake data and stuff like that. Here, you don't need to do all of that because you are just operating on the real thing, right? And finally, the one other stuff we wanted to show as well is that, okay, this is great that you operate on a real phone, but then aren't you limited with the device form factors that you have? And yes, but essentially we do a trick and we say, we rescale the root element that you are operating with, so you can quickly see how things would look like if the size or essentially the form factor of what you're operating changes. In that case, I have the image. You notice at the beginning it was not centered correctly, so I added some centering constraints. It doesn't behave like I want, so I'm changing the width to be spread. And you can see that I can quickly interact and see how it would react if the size would change like that. And the final stuff I think I'm doing here is that the button is not correctly constrained where I want. It was just constrained in the center. Here I can just add it as saying, well, the button is going to be below that image. And again, I can quickly iterate and see how it actually works and feel on the device. Let's finish this demo. And so the idea for us is that once you do all of this editing, you end up with just this JSON specification that you can easily copy paste into your actual application. If we move some of those functionalities straight into Studio, there will be more opportunities to essentially directly operate on the JSON that is packaged in your application.
I just also sort of add that the part of the idea here is that we use this as a playground to experiment on the design of this kind of UI and what can we achieve. It could be valuable just simply because it's a light standalone way of editing live applications, because this you can imagine this being used in the middle of any sort of real application, like somebody with Twitter or something like that. They're running their Twitter, yet they're being able to adjust it. The developers of Twitter, obviously. But the other thing is, this is also platform independent in the sense that it's just modifying and interacting with a JSON string. And that means that if this was manipulating legacy views with a JSON string, or desktop compose, or any kind of other platform, the entire link concept will work in those situations.
The one thing that I would add, there's a question in the chat about creating or passing parameters to JSON. The idea is all those variable sections that we have, you could actually override the variables. And if I remember, on the current repository, you can do that. There's actually much more we could do from that aspect to make it more, parameterized. But yes, we are thinking about that use case too.
So it does in fact support variables that can be inserted and a separate runtime, like insertion of variables, things like that. So it is. And if there's something people feel is missing, we own the JSON syntax, we own the front ends. We can add more features as people need. Other people can help us add features, as it were.
So where are we now? So first, we released ConstraintLayout 2.1 in the end of July. We released the 1.0 first beta for Compose, same thing. And while I actually left Google in August, so I'm not going to be as productive on ConstraintLayout going forward. I joined Rivian working on UI. And by the way, if you're interested to work on interesting stuff with electrical vehicle, we are hiring. But I essentially, leave the project with John as the tech lead. And John?
Yes. So, and since he has left, we just released on Friday 2.1.1, just a small minor update of ConstraintLayout 2.1.1. And you can see the release on GitHub. You could also, Maven repository, etc. We also released on Friday ConstraintLayout Compose release candidate 01. We are looking to try and stabilize this version and release it. Please try it. If anybody is actually there, give us feedback. We're going to let this. So we kind of frozen the feature set at this point. And actually, everything you've seen demonstrated here is in this release. The motion layout section of it, you can sort of think of it as more of an alpha than the constraint layout section. Constraint layout section has been actually around for quite a long time, but we will keep all the functionality you see in this current release as we go in, and we're hoping by the end of the year to sort of achieve or get close to feature parity with 2.1. But under Compose as well. And going forward, we would expect to see, you think of it as 2.x releases as we iterate on improving the legacy system and fix bugs and address issues or feature sets that people need. Realize that the 2.1 is actually going to be around for a long time. And we're going to be continuing to work on enhancing it and working on migration strategies, etc. Please give us feedback. The website, the GitHub is great. We have lots of contributors already. If you want to contribute, talk to us. It's very easy. A lot of people have. In fact, Circular Constraint was done by someone outside. A lot of work has been done by other people. There's a issue tracker. The wiki on this is one of the first places when we add a feature, we go to the wiki and just update it and talk about it. That's it.
We have a couple of minutes for questions. If you want.
Yes, thank you so much. I know a lot of us were amazed by what you were sharing, especially with that link application. There was a lot of excitement in the channel. If you're not in that channel, go ahead and join ConstraintLayout, MotionLayout, and Compose and ask your questions there. I know there was some answered in the channel as we were going, so thank you so much for following along with that. with the moments that we have left, we can answer any other questions that come in, as well as talk about some of the questions that came up over video so that we have it for people who are joining later on.
Yes.
So one of the first questions that came in was, what is the performance hit when using constraint layout in Compose, especially compared to row and column?
Yeah, so that's a good question. The performance should be roughly similar to the view framework performances, because as I mentioned, we are using the same core library. There's a few differences, and there's we're actually working on improving some of that. There's some opportunities for improvement, but all in all, it's I think it's comparable. The main distinction is simply that on the view system, nesting linear layout was not a great idea. With rows and columns in Compose, it's been kind of thought to handle that much better. So if it's purely in terms of performances, I think rows and columns go a lot further than what you had on the view system. So it's more like, if you want to use constraint layout, it's more if you're interested to do this kind of layout motion, or if you want to do the separation of concern, or if you just want to specify your UI with relative positioning.
Yeah, in general, if you just need a simple row, and even in 2.1, if you just need a linear layout to fit your stuff, just use the linear layout. Don't switch to, use the smallest tool you can to get the job done. But at scale, you may find rows and columns starts to get difficult. Rows and columns are a lot more efficient than linear layouts were in terms of nesting. So I think it's a good idea to kind of shift a little bit more towards rows and columns before. But there are just things that get really, really difficult to try and achieve with rows and columns. That's why we had relative layout in the previous, from the start of Android. Okay, any other questions? And meet us at Slack. We're going to stay on for a while, and I'm available to chat. So
yeah, we are easy to be reached out on Twitter as well, or on various Slack channels. So don't hesitate. We welcome feedback as usual.
Awesome. Thank you so much. Let's grab one more question from the Slack, and then we'll head to our break. Does Compose constraint layout follow the same lifecycle / recompose cycle as the rest of the composables?
Yes, that's an easy. So essentially, internally, we essentially cache the various things. So if the constraint set doesn't change, you should not have a composition, and vice versa. And you noticed it in the example where I was just toggling between two constraint sets. So it's only then that we were doing the animation, right?
Gotcha. Thank you so much.